Hot damn. Boy, it feels good. Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and I missed you. All right, before we get going here, I want to say thank you to all those that have sent in cards and or projects and or tooling to play in the shop with while I was out laying around on bed and in the recliner. It's been 6 weeks now, and I got permission to be in my shoe, and I can start trucking around as I feel comfortable with. Okay, I start out the morning with a pain level about 1, and towards the end of the day I'm probably like a 3.5 or so. Nothing that aspirin can't help me with. All right, so I am full speed limping ahead, and there is one. While I was out, I did a lot of designing on my Fusion 360, and I got 2 major projects ready to get into the cam situation and get them going. I got the Get Her Done shop clock with the Coyote and the Roadrunner, and the clock with the cactus hands. I've got that all drawn out, and I've got it laid ready to put the cam to it and cut it out on the X-Carve. I also got my the gauge assembly that I want to replace the speaker grill. That's what it is. On the center of the dash there's a speaker grill, and you pop that out and you'll be able to pop in the gauge assembly that I've designed, and I've been working on that. I just kept going at it until I got the results at the end that I wanted. And I've been working with John Saunders on kicking it back and forth, and he's helping me get through with the cam setup, the portion of running it on the machine, and I'm going to be telling the plasma cam what I want machined, and so I've got to work with the cam and get it set up and get it installed into the plasma cam, and I'm going to be using the carving software and an attachment to go ahead and machine out that part on the plasma cam. I have a high-speed spindle and a couple other things that I'm going to be modifying. Instead of using the DeWalt that comes with the system, I'm going to be setting it up so that I can run a little different unit, and I'm going to try. It's only got 2 inches of travel now, and I would like to have a little bit more travel, so I might be doing some modifications on that. So this is projects coming up. Right now I'm out here and I'm open to public April 1st, and until then I'm working at my own pace on my own projects. Part of my projects that I'm working on that I consider my own project because they're Comshaw work, and I've been trading off with Nathan a couple items, and it's time to get his shaft made. We got the material, we got the drawing here. He sent me some components that will be bolting to it, and we're going to be getting into that as soon as I finish this up. And all we got is the auto oiler to get completed on here, and then I can start turning some chips. And this is the machine I want to use. We got the readout now. He's got a lot of increments and a lot of different diameters and some really unique parts to the shaft, and this is going to be pretty awesome to make some chips on this and play with it. And we're just about ready to rock and roll. Now you can see that I've made, in the last couple days, I've made this guard here for the run here, or the rack for the readout, because it just had the plastic covering over it. I want to make sure that I don't burn it with chips and stuff, and also I want to make sure that it can handle some impacts. I'm saying that I might drop something. It's happened in the past. I got this guard down here. These I had to hand shape. They're 1/16 aluminum, and my finger brake it's 16 gauge steel, but it doesn't quite want to handle this aluminum in the length that it is. In fact, I had one part here. I actually, this is the second one. I had to make another one because it wanted to shift in the finger brake before I realized I wasn't able to do it. And anyhow, I kind of hand shaped these, And this one here I hammered over a piece of hex stock, so I got it to be crowned, and it's good. It's gonna keep the hot chips out of here. This is just flashing, and I can bend that fine on my brake and shear and all of that. And so I got this set up so that it'll follow the track, and I got this as long as I can possibly have with the carriage all the way up in here. And we're just bringing this carriage back. Let me bring it back about there. That gives you an idea. The auto oiler, I've got the first tube up here, and we have an insert plug that we need to make for that port, and then the port on each ways on each side. And I got that in there just so nothing will fall in there. Now I'm going to be machining out this copper rod here to make those 3 ports, and then it'll get soldered onto this length, and then we'll finish up the rest of our flex line and how that's going to run. And we have another copper line that we're going to have to bend that's going to go in for this one, and we have that extra flex line right here that we'll be plugging into that. Now I don't have chucking capabilities in on my large closing because that only comes down to about 1/2 inch. And my precision 3-jaw for this machine, I don't have the backing plate made for it yet. Pierre Broderie sent me this backing plate, and before he sent it, we took some dimension and everything else, and this is going to fit the back of my 3-jaw perfectly, but I don't have it done yet, and that's not my project right now. With this lathe, I was given a 5C collet attachment assembly, and it has the quick release and everything else on it. I have all those components over there minus these 2 units here, just to show you that we will be running a collet in here, and I will be able to, of course that's 3/16. I don't even have the right size yet because I haven't dug out the collet out of this bag. This bag was given to me just like this. In fact, I posted this picture on Facebook looking down into it, and everybody panicked and says, "Oh, you're throwing those out," because it looked like a trash can, and it looked like I was throwing 5C collets out. Okay, I am a tool clear. I'm not going to throw things out. Okay, I will give things away in the toolbox giveaway, and I'll trade and dicker and all of that just like everybody else does. I have been working on my collection for over 40 years. I started out with tools, then tooling, then machines. And waiting for the right time, the right spot at the right time is how you get some of the best things. And other times you're hanging over the used tool truck or whatever comes rolling in the yard on a weekly basis. Old Rod over at North Star Propeller, when once a week he would roll in with this truck. This truck was allowed to go in any neighborhood without getting molested. That's how bad this truck was. But we'd hang over it, and we were drooling on what was inside the bed, not on the truck. We were drooling, hanging over the bed. And that's where I picked up things just like these 5C collet, or not 5C collet, 5-4 Morris taper sleeves. Well, almost dropped the Primo one. Okay, I have these too, and this is a CTD, and this is a Collins company, Clinton, Iowa. Now these have been around the block a couple times. When I was in the shipyards, I did a lot of work on a lot of big machines. Tailstocks had 5 Morris tapers, and also HBM, a lot of the spindles had Morris taper in mounts in the end of theirs, and you had drift and drawn. You actually had pins that would come in and they would hold in your Morris taper, but you also knocked that out, and then you had a knockout. So sometimes you had 2 ports on the side of your receiver for your Morris tapers. Getting off subject here a little bit, but I needed number 5 to go in here. All right, and that fits perfect because I want to go ahead and dial this tailstock in. Now when we left before the holiday season, the last thing I did was dial the headstock into the bed ways of the bed, and now I wanted to dial that tailstock to the lathe. All right, so now I could run one of these smaller centers and put another sleeve in here, But every time that you put another sleeve in there, you take another chance on having a little bit of run out. And I'm probably going to have just a little bit of run out. And we'll pop that in there. All right, I just wanted it to seat pretty good. All right, we're going to pop this in here. All right, now I'll take an indicator. And I'm just rolling it over here to see. And I got a thousandths run out there. Maybe a thou run out there. Okay, at least I know what it is right now. And it could be just a little bit of a blim. Okay, it really could. I don't know if this is original or what surface on this right here. There's a chance of it. We're within a thousandths here. Okay, now basically I'm going to take, and I want to go between this center and a center over here. Let's go ahead and take out this live center. You could run the live center if you wanted to, but let's just take the dead center here. Okay, now I have a rod here, and I use this. I use this on the tracer in the closing a lot. When I want to take a straight line and I want to just kind of like make an angle or whatever, and I can adjust it in between the two pieces there. Well, let's take this. We'll slide our tailstock up to here, and don't worry, I'll be machining a new handle for this right here. But this is temporary. I have another one that's over here on my feed direction here. All right, we got those two centers in there, and I'm going to go ahead and take a little bit of extreme lube in here. It's just good practice. If I was going to turn something in between centers here, I would be putting extreme lube in here. Anti-scoring, okay? Concentrate center point lubricant, all right? CMD, number 3. All right, this tube's, I've had this ever since I left California. And so we're going to put that in there. We put this center in here. To where there's just a little bit of a friction there, so I know that there's no play in there. Okay, now I could go ahead and I could check this and make sure that this bar is running true or concentric. So then I could move my carriage back and forth, and you can put an indicator up here, and you can put an indicator on the side, and you can crank this thing back and forth, and tell yourself where you want to go for your tailstock. But I can set one indicator up here and never stroke my carriage back and forth and align that tailstock. And this is how I'm going to go about it. I'm going to take a clamp from the button head kit here, and I'm going to take a rod. Let me see, which way am I going to want to do this? I might be able to do it this way here. Okay, I'm going to tighten this up here. Okay, I've got the indicator clamped to the bar. This clamp comes on over here, and the button is against the surface of this diameter. This diameter is 4.5, and it's in about 1/8 of an inch. So we're gonna consider the sweeping diameter of this, and I could take a little bit of bluing or whatever, make a line there and a line there, and then take a pair of dividers and get it exactly. But we're going to estimate it to be 4.25. Okay, 4.25, and our bar length between the centers is 23.5. All right, we want to work a ratio of that 4.5 or 4.25 to the 23.5. So we take 23.5 and we divide it by 4.25, and that gives us 5.529 or 5.53 ratio. Okay, so every thousandth that this would be out, it would be 5.53 thousandths in the direction needed to move the tailstock to create the alignment of the tailstock to this face here. All right, I don't know what we're running out here because this is the first time I put it on there. So we got 0. I'm gonna get my mirror here I got somewhere. It might be -0.5. And we got 0 there. And 0. 0. Okay, I'm going to go ahead and change this out to a tenths indicator because I'm not reading enough run out in here, and the chances of that being dead zero, if it is, then I ought to go down and buy myself a lottery ticket. All right, let me do something here. Okay, we put our Michitoyo test indicator here, and we put the rod up here so we can grab that dovetail with this clamp here, and we got it on the face here. We set it at 0 there, and we're sweeping it around. And each point does stay 0. I mean, if I lightly touch it, you know, as I'm turning, I might get like a 0.5 thousandths fluctuation or whatever. But basically, I'm reading within tenths that are hard to see on this indicator. I'm going to bring you in a little closer. We're going to sweep this. Now, if I was out, I would take the amount of run out and multiply it by my ratio, which was 5.529 or 5.53, and I would put an indicator here and put it against my center at this end, probably at the end of the part here or on my center, one real close to that contact area. Probably it'd be closer if you put it right on the part. And then I would take an Allen and I would adjust the tailstock over or towards me, depending on what side it would be off here. And that's how you can align your tailstock. If you aligned it right here and then you had an indicator and it was on here and you ran it or whatever, that would be wear or dip into the bed. But we didn't see a lot of that on our test mandrel, and these are hardened ways and they look really good shape. And with this being ground or scraped ways and everything else, this thing is I'm surprised that tailstock is pulled off, taken apart, painted, and put back together. I didn't take the split line apart on it, so you know, This could have been dialed in before by somebody else, and it's just holding that trueness, even though we moved the head here and everything else to align it to the ways, but it was aligned to the ways at one time or another. Excuse me, before. Let me bring you in close. We'll make one sweep around here, and then we'll get on with our project here. Okay, now I've got this set at 0 here. This is a tenths indicator. Okay, so each line that this thing moves is 1/10, and we got like a 1/2 a tenth there. Let me see if I can. There we go. All right, down here at the bottom, we're 0. Okay, we're coming up on your side. Barely off of the 0 mark. All right, now you wanted to see that. Okay, there is movement there. All right. And we keep constant in one direction here. Let me see. There's 0. Got like a 1/2 a tenth there. Like well, 0. When I had my hand on it, it was a 1/2 a tenth, and then it was 0. And we're just off of the 0 line, probably the width of the needle. Okay, so it's time to go play the lottery, right? All right, let me get a brass rod here and knock this out. There we go. Okay, we're ready to go ahead and put our collet assembly together. Now let's go over to the table. I'm going to spread out a blanket here, and we're going to dump that bag of collets out on there, and we're going to go through that, and then I'm going to bring out a few other features that I've been hoarding and saving along with this that all go together with the 5C collection that I've had for 40 years. All right, plus the new bag that I got, what, 4 or 5 years ago when I got this lathe. All right, and we're almost ready to start turning chips on it. Okay, we're in here at the welding table, and this just happens to be a 4x4 sheet that I had in on a plasma cutter that I'm cutting out a few things, but the plate is mostly whole, and I got a blanket here so that we can go ahead and dump these out. Let me bring you in a little closer, and let's spill out this bag, and I'm going to explain the whole assembly that goes through the spindle of the lathe and holds the 5C collets and the engagement on the back of the lathe. Okay, we showed you this part going into the end of the front of the spindle there, and the 5C collet goes into it. It has a groove on the side of the 5C collet which lines up with the pin that's in the side of here. Those threads protrude out of there, and on the inside of here is threads that pull the collet into this piece right here. Now, the other end of the spindle has got an attachment here that gets set screwed on there, and then it has a serration or a cog around here, which is increments of tension that you do put on those threads. That mounts on the back of the spindle, so this whole assembly goes through here, and then here's the little indicator or the pin. When you rotate this around and you thread this until it's tight, and then engage your clutch. So it's like a throw-up bearing right here that actually engages the pulls down the collet, closes it, and then you can push it forward and it releases it, so you can change rods or move a continuous run straight on through this tube into your working area out in front of your spindle. Okay, and this is the linkage here, which the pin goes through here, Let me hit the hole. There. Okay, and this drops into a block on the back side of the lathe, and I'll show you that over at the lathe, and we'll be assembling this whole thing. But this is basically the whole picture. The whole assembly is just like that. Okay, collets in the end here. This is how it attaches. This is locked to the spindle here, and your clutch goes in and out and pushes and pulls your collet at the end here. So it either pushes it in or pulls it. Push in, pull. All right. Well, let's set this off to the side here. Let's go ahead and let's dump out this trash can. Okay, now this is not an ideal way to store your 5C collets, okay? And it, you know, and really putting them in and out of the boxes, that's gonna last only so long. We're actually gonna make a rack that will hold our 5C collets, but we need to find out what we actually have in here. And so what we're gonna do is we're gonna go ahead and we're gonna go through and we're gonna pick all the sizes. We're gonna lay these out, and we're going to see what we got. Okay, we got them all out of the wrapper. Some of them still have that sealant or the lubrication that they put on them when they manufacture and package them up. Okay, from 5/64s on up to 15/64s by 64s, and then it goes quarter, 5/16, 3/8, 7/16, half, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, 1 inch, and there's an inch and a 16th here as well. All right, now that's just in that one collection. Now, I don't know, we're bringing out the atomic fireball. All right, this box is pretty well trashed, and this just happens to be a collection that I've been keeping for over 20 years. And let's just see what we got here. And there's a 3/16. Now these are hoardings. This is a buck. There's 5/16. Some of these got just a little bit. Now this has got actually some pins in here. One pin's missing here, but this was an extended collet there. I don't know what size it is. It looks like quarter. Okay, this one collet that I said was the extended collet here, and if you look at the face of it here, there's 2 pins in those slots, and there's an actual empty there. I'll have to get another pin to put in there. This is called a pie collet, and it likes pie jaws. Okay, so those pins hold the collet in the holder, and then you can machine a bore or a face recess in this so that you can grab small rings and stuff like that. We'll come up with a project where I actually use this. So we'll put this in, and then we'll machine the bore or the face of it to receive a part and hold it like pie jaws. So that's what this collet is all about. I just had a brain fart when I first saw it. 7/16. There's another 1 inch. There's a 1/16. There's an 1/8 of an inch hoardings, and 3/4 hoardings. And there's a 1/4 inch hoardings, a 7/8, and a 5/8. Some of these are used, some of them are in pretty good shape. So we do have a good selection here of 5C collets. So it does make it worthwhile to actually have the collet attachment for the lathe. And and if you're a collector like me, then you might have a couple other attachments like this that fits in the mill and holds your 5Cs and lets you do indexing with the number pin here. Or you might have a quick ratchet 5C holder So you would adjust it until it throws out just right. There we go. Okay, and then you would index it like that. So 5C collets are extremely useful and universal for lathe work and also for mill work. Alright, let's go get our collet assembly in on the lathe there. Okay, the first thing we're going to do is just making sure that there's nothing in there. And we're going to go ahead and we're going to seat. We're going to seat the holder in there, and then we'll be able to insert our collet. And our collet is ready, but we're going to go ahead and insert the shaft and drawbar on the back side. Okay, we're at the back here. We've already mounted this plate. It was on here when we painted this. We pulled it off and we put it back on. We didn't put a coat of paint on it, but we can paint it anytime. It could dry overnight. We can remount it. It's just 4 Allen screws in there. This is the receiver that goes on the back side of the lathe, and on the spindle there's the set screw marks, and there's one dimpled set screw where this is supposed to line up, and that's the one we want to shoot for. And get that one in there. Then the other two are going to set where they were. You can see that this was installed one time off. It wasn't on properly, okay, but we want to install it properly this time. And I don't have a ball metric set yet, and that would be real handy to have right here. But with the set screw loose, you can feel that it's in that dimple hole, and that's the key to it, making sure that it's in that dimple. And then after that, then we can tighten up the other two. All right, we got that one tightened. Now this here, I do have a ball end mill, Allen, and I can get that one in. That one's tight. I don't know why there's 3 in here, but there is. Okay. I'm gonna go ahead and put this in gear here, and I want to spin it. Okay, so that's not the truest thing, is it? we could spend 5 minutes on talking that, or we could spend 5 minutes on talking extreme pressure, right? All right. With those set screws there, I'm wondering if somebody didn't try to create a way to align that. And actually, if we took our mag base, see if we got enough on this here to, yeah, we can't. Okay, look at that. Awesome. Okay, you know what I'm doing, right? Okay, well, I'm just reading how far this is off, okay? And that's 1/32, okay? That's the high. That's the high. All right, let me get my rawhide mallet because I want to try tapping it. I'm going to measure the inside bore on the outside of that sleeve, or the spindle too, just to see what variables we have there. Okay, we loosen it up. We can feel that there's play in there. I mic'd this up and this, and we're borderline of 9 to 10 thousandths play in here. Okay. you know, really the true way to fix this is go ahead and bore this out slightly, put a sleeve in there, and then rebore it to fit the tight diameter. And we'll probably do that so that, I mean, I see us using this quite a bit in the future here. But for right now, let's just see what we got here. We got like 4 or 5 thousandths of thickness in a piece of paper here. And let's get a piece of scissors and we'll cut a piece, and we're going to wrap it around here and put it in there. We're going to see if we can minimize what we have for play in there. But we don't have any 5,000 shim stock or 4,000 shim stock. Okay, we found our scissors and trimmed a piece. We got the paper in there. We're leaving the set screws sticking up out of there. Let's see if we can get this over there without folding the paper. That feels nice and tight on there. I did get my rawhide, didn't I? Okay. I'm going to pull that set screw out because I want to stare down. I want to stare down in there, and I want to see that I'm over that. I'm almost there. Okay, we're home. Okay, before I engage it here, or I mean tighten that down, let's see how she's running. A lot better. A lot better. This is actually running out a little bit here, but this right here is... Let's see what we reduced it. We can... Okay, 9 thousandths. And just for... There's 3 right there. Let's just go ahead and we're going to put our set screw in here, and we're gonna run it like that. We know what the problem is now, and somebody just didn't take and use an indicator. This is another thing where free is not free. Okay, I gotta do something. Okay. Like firewood. And firewood's not free too. You still got to chop it, cut it, split it, stack it. All right, nice. Okay. And I'm happy with that. I mean, as happy as I can be with what was given to me free. All right, now, okay, we want to go ahead and put just a little bit of oil on this tube here that's going through there, and this is almost like a bushing or bearing diameter right to this. Now this thing is not running super true, so we're gonna feel. Well, it's not binding it all there, so let's put the collet in here. Okay, now we're screwing it in. Now we can start to feel it's tight there, but we want to go ahead and we're going to take the piece of rod and we're going to stick it into the collet, because we're adjusting this to tighten on the collet. Okay, now before we do anything, we got to put the link in here, and I'm not sure which way goes in here, other than one end there and one end there. Okay, and it's a little too tight, so we're going to back it off a little. That's a little too loose. Okay, this pin here, we're locking that in. Okay, tight, loose, tight, loose. All right, now we can go around to the other side so that we can show you the collet grabbing and locking, and we'll spin it to check our trueness. Find a rag. Okay, release it. That's just pulling the handle forward. Lets you slide your material in and out, and you push back and it locks it in. Okay, and you can see how true that runs. Okay, what we really want to see is we want to see how true the piece of material is running in the collet. And it's running about 1/1000. Right. Find a neutral here. A little less than 1/2 right there. The shaking had to be, yeah, the shaking. Lathe shakes a little bit because this is running out on the back, and the run out and the weight wants to shake it a little bit, and it was shaking the indicator. Okay, but a free spin right here, it's holding it less than 1/2. And this is just a rough piece of copper. It's been thrown in and out of the rack and everything else, so it's not even polished or anything. So we're happy. We're ready to go ahead and machine a couple plugs to put into the lathe for the oilers. You know, it's a shame, as I know that this is a quality product here. This is manufactured by Royal Products, Hop Hog, Long Island, New York. Okay, but because this was jerry-rigged, this adapter in here that was made for this machine by somebody that owned this machine before, kind of jerry-rigged it. Okay, and I know that if this thing was not moving and this thing was spinning 100% perfectly true, this thing would not rock and roll like. Things that make you want to go, all right. We're going to go on to a couple other things that we got going on, and we'll come back to cutting these plugs and creating our oil path and actually concentrating on that project itself in the next video. Well, I'm back in here at my X-Carve, and I have a couple programs that we're going to be playing with. This one right here is the gauge assembly that's replacing the speaker grill insert on the Porsche. We're going to go out there in a minute because I gotta check on it anyway. I have a trickle charger on the battery and stuff like that. It's stored for the winter. I keep it covered up and only drive it during the good season between spring and fall. I went ahead and, of course, I've got a few things here, and talked about the job I'm going to be doing for Nathan, and he sent me a spindle here, and this spindle is 220 volts, 5 amp, about 400 hertz, 24 1,000 RPMs, and I have a variable control for it, and we'll be initiating that. This has got an ER11 collet. So what it came with a 1/8 collet, and I went ahead and got on the internet there, and John Saunders referenced a company. So this is Mari Tool, and the first thing I did is I got right on there and I ordered 3 more collets so that I had the variable capabilities of putting in end mills and router bits and cutters that I need to have for the project. I'm going to be changing things out, and of course you want large ones so you can rough off material, and then you want to get down into smaller ones where you need the more detail. And we're going to be going in with multiple cuts, and also I will have some I'm going to call them hairy situations in on this project that I got designed out. Now I sat there in my recliner chair and for a couple weeks, and throughout my time between my my movies there and stuff in the recliner, I went ahead and I drew this out, and I also finished creating all of my Get Her Done Coyote Roadrunner clock, which is going to be happening on here. I just happened to pull up the big sheet that's going to be the one piece up for the whole back, and it's actually a little bit bigger than this table, so I'm either going to be doing some indexing, or I'm going to have a 2-piece background piece to create that entire project, because this is the large X-Carve table, and it's about an inch shy all the way around of doing my entire project. But if I cut it in half, I'll be able to get it on here. Alright, so this spindle, of course, it's too heavy to run on the X-Carve here. This thing probably weighs as much as that whole gantry and arm. And this is water cooled, and there's a lot to it. But the plasma cam, I have the attachment to do carving and 3D work on it. So this is going to be a super learning project for me and anybody else that wants to share along. And John is he's intrigued already because he's got this project up here now, and he's helping out with the cam to create the whole cutout, and I can't wait to watch that video and get started on what I'm going to need to create some chips to make up that piece. Well, let's go ahead and take this piece here and run out to the porch there and put this in the dash to fill that little void hole that I got in there now. John has one of these also over at his shop there, and he has the actual gauges that go into the project here, and he'll be sending those back my way here soon, I hope. Anyway, just kind of tagging bases on something else that I was working on while I was out, off of my feet here. All right, I just unplugged my little. I got a long time little trickle charger here that kind of babysits my battery here, and I was just kind of checking that, and you can see you got juicy. The light lights up because it's on here, but I unplugged this so that I could have the lights here so that you can see in here. I'm dying to get this back on the road. Of course, I don't drive it when the weather doesn't. It is dusty, and we need to get it washed up and stuff like that. We have a few things that we're kind of nitpicking on it, but anyway, coming out here and just kind of giving it the eyeball and getting to sit in it. Let's go plug this into the dash here. Okay. Now this wire, this is my microphone for my Bluetooth phone capabilities with my radio and everything else. So we're going to be we're going to be incorporating that somehow into this piece here, and I don't know if I might change this and actually stick it to the top. We'll give that a look. And so anyway, and this, I measured this angle here versus the part here, so that hopefully when we get done manufacturing that part, it actually kind of hugs this a little bit better. That outside cowling will match this right here, and the gauge faces and everything else will be just like that. Everything is pretty well straight out. I mean, I could have made them so that they angle over here a little bit, but I don't really see them. I mean, when you're driving, you're not that far, you know, it's not like it's a wide car. So in a face, I might actually do a simulated aluminum looking face, just like I did on the radio down here. So anyway, sure feels good. I do miss my little baby here, and of course my left foot is still healing, so I'm not even able to really pump on that clutch foot right now. So this is just a project in the works, and can't wait for it to get going. The piece that actually I sent John is a better example of this angle here. This one here is a little bit hard. You got to figure that this is this car actually was made in '84, December of '84, November or December of '84. I think it's actually 11 or 12 '84. So this car is you know, pretty old, and the sun has had a lot of time to be on the dash and stuff. I've actually put this is the second over dash that I put in here, and real happy. It came out real nice. Well, I did notice that this is just a little bit narrower around here than what I made on the one up here, but it's still got the same characteristics and everything else of it. So it's gonna fit in there really nice. I'm gonna try to, you know, the milling finish, I'm not sure how I'm going to take that milling finish and make it into the wrinkle, or what I'm actually going to do. I mean, this isn't wrinkled. This is like a grill type of look to it. So it's going to be unique in its own self. So I'm not sure if maybe just a polishing on the Delrin will give a smooth. If I go for full smooth and aluminum face, it might be something to look at. It's, you know, I'm still envisioning the gauges sticking out, and we'll just have to see how it looks, and go from there. Boy, I remember it was just a couple months ago. Just a couple months ago, I went and picked this up. You know, I can't wait. I mean, I sprayed oil all over it, so it's not going to rust up any more than it was, and I am going to be cleaning it up now here probably next week. I'm going to go ahead, and I have a cord long enough to go from my breaker inside the shop all the way out here, and there was a hint that possibly the back gear might need some work. And I kind of like to know that right off the bat. I'm going to be taking this down and dressing up the paint job and stuff like that. I don't have to do too much on this, other than clean paint, and we will check out if anything's wrong in the back gear. And you know, it does need some attention. It does need some attention. It was in a building that was able to have a little humidity after the old timer passed on, and the roof was almost caving in on this place here, and it was just, thank you for letting me have this one here. Now I'm going to be changing out some of the things on my other mill with this one here, and I've already found a home for my other mill. Dennis Nolan is going to be taking ownership of my other mill when I move it out, and it'll be his to play with after that. Now this has got a little shorter table, but a little wider table, and I think I have a little bit more throw on the knee than the other one there. So the knee is beefier the table smaller, but the travel distance is a little bit more. So, you know, other than that, the readout really is, it was so old, but the kids that moved this out of the building destroyed the rail, the scales. The whole thing was working before they moved it out there, and at least so the rumor is, and of course they trashed out the scale. So I'll be taking my readout and putting it on this as well. And so we have a lot of projects to be getting done this year, and today you got to see a little bit of what shop therapy is doing for my foot right now. All right, until next time, get her done.